Today on Quickly Quantum, $100 million, 5 years, and one of the biggest philanthropic bets yet that quantum security needs fixing before it's too late. Is money like this enough to get ahead of the threat, or a drop in a very big bucket? Before that, in the headlines, the UK just dissolved its own science ministry, and nobody's sure what that means for quantum strategy. Galaxy Digital is spending real money to quantum-proof Bitcoin, and Singapore's military just teamed up with IBM. Welcome back to Quickly Quantum, your daily brief on the quantum frontier. It's Wednesday, July 22nd, 2026. Let's get into it. Now, first up, a big shakeup in London. The UK government has dissolved DSIT, the Department for Science, Innovation and Technology, and instead given its AI minister a seat at the cabinet table. Per the BBC, DSIT's responsibilities get split across other departments, and the standoff technology secretary job disappears entirely. Kanishka Narayan, the UK's Minister for AI, posted on X calling it, quote, a sign of his deep commitment to AI's importance, referring to the Prime Minister, and added, quote, AI is likely the most significant technology in human history. Its impact will dwarf other things. That post pulled in nearly 1,500 likes and over 282,000 views. Here's the quantum angle. Britain's built 12 years of stable policy on this, from the 2014 National Quantum Technologies Programme through the £2.5 billion National Quantum Strategy, and companies like Riverlane, PsiQuantum, and Oxford Ionics, which just sold to America's IonQ for $1.075 billion, the biggest UK quantum exit ever, show both how strong and how fragile that position is. Existing quantum programs reportedly stay in place for now, but with no dedicated tech ministry, who's actually steering strategy from here is genuinely unclear. Now, sticking with money and quantum threats, but shifting to crypto, Galaxy Digital just launched a Bitcoin Quantum Readiness Initiative, committing up to $5 million in developer grants, a research program, and a new quantum advisory council that includes University of Calgary professor Barry Sanders and Boston University's Eran Tromer. As @BitcoinNewsCom put it on X, quote, Galaxy has launched the Bitcoin Quantum Readiness Initiative, committing up to $5 million in developer grants to help prepare Bitcoin for future quantum computing threats. Here's why it's not paranoia. Roughly 6.9 million Bitcoin, about a third of everything ever mined, sit on-chain with exposed public keys, meaning a sufficiently powerful quantum computer could, in theory, crack the elliptic curve cryptography protecting them. Coinbase made a similar move back in January, forming its own advisory council, and its April position paper concluded quantum computers don't pose an immediate threat, but that prep should start now. Worth saying plainly, no quantum computer on Earth today is anywhere close to breaking Bitcoin's math. This is precaution, not panic. Now, over in Singapore, the Digital and Intelligence Service and the Defense Science and Technology Agency have partnered with IBM to explore quantum computing for military mission planning. Things like logistics optimization, where you're juggling constraints, resources, and timelines all at once. The official Ministry of Defense account @MiniDefSG announced it on X, saying the partnership will, quote, explore the use of quantum computing for complex mission planning, such as logistics optimization use cases. But even Singapore's own commander overseeing this was candid. The technology remains nascent, and practical, real-world benefit is still years away. That candor is refreshing in a space that loves to overpromise, and it puts Singapore in company with a growing number of governments treating quantum less as a weapon and more as a long-term research bet. Now, a quick one for the error correction crowd. Rice University has joined the Department of Energy's Quantum Science Center, adding its research muscle to the national push on quantum error correction, the family of techniques that let you build a reliable, error-corrected, logical qubit out of many noisy physical ones, still the single biggest bottleneck between today's error-prone machines and a truly fault-tolerant quantum computer. The Quantum Insider is reporting this one, and we haven't independently confirmed it beyond that, but it's a straightforward story. Another serious research university plugging into a serious federal quantum center. The Quantum Science Center already counts national labs and universities across the country among its members, and error correction is the topic that keeps showing up whenever the conversation turns from lab demos to something you could actually trust with real workloads. Not flashy, but this is exactly the unglamorous foundational work that has to happen for any of the bigger promises in this field to eventually come true. Now, Quantinuum's back in the news, and this is the same company we've been a little skeptical of before. They've had a habit of re-announcing incremental hardware milestones. Today, it's a joint white paper with Japan's SoftBank called Quantum Computing Frontiers, mapping quantum chemistry and graph analytics use cases onto Quantinuum's hardware roadmap. That's the Helios, Sol, Apollo, and Lumos generations of machines, trying to pin down exactly when specific problems stop being solvable on classical computers alone and start actually needing a quantum processor. At AI Stock Savvy summarized the paper on X as mapping commercial use cases directly onto Quantinuum's hardware roadmap. Here's the catch. This is a paper co-written by the vendor and its own commercial partner, explicitly framed as a conceptual framework, not financial guidance or a commercialization commitment. Treat the timeline like a projection, not a benchmark. And last in the headlines, a fresh seed round for hardware nobody's talking about yet. PhotonQ, a University of Illinois Urbana-Champaign spinout founded in 2024, closed an oversubscribed $4 million seed round led by Playground Global, with Cerberus Capital Management, Illinois Ventures, Roadrunner Venture Studios, and MFV Partners also chipping in. The company builds room-temperature quantum memory, hardware designed to store quantum information without the elaborate, expensive cooling most quantum systems need. @RaisingFi tracked the round on X, listing it simply as a $4 million seed deal out of Urbana-Champaign, Illinois. This is Quantum Computing Reports reporting, and we haven't independently verified it elsewhere yet. It's early-stage money for a young company, and room-temperature quantum memory at commercial scale is still unproven. But if it works, it chips away at one of the industry's biggest cost problems, keeping quantum hardware cold enough to function. Now, if there's one theme tying today's headlines together, it's that the money and the governance around quantum are moving just as fast as the physics, and today's biggest check yet just landed. Our main story today: what happens when philanthropy, not a government, not a vendor, decides quantum security governance is worth $100 million? The William and Flora Hewlett Foundation announced a 5-year, $100 million initiative at the Aspen Security Forum called the Emerging Technology and Security Initiative. It's built to fund research and organizations working on the security risks of 3 technologies: artificial intelligence, biotechnology, and quantum computing. This isn't a company promoting its own roadmap, and it isn't a government spending taxpayer money. It's a private foundation with 60 years of history in technology and security policy, the same one behind a decade-long cyber initiative that effectively established cyber policy as a field, putting real philanthropic capital behind work that doesn't come with a product to sell. So why now, and why quantum specifically? The initiative's framing is worth sitting with. It wants to reduce the security risks posed by fast-moving technologies, quantum computing chief among them, while safeguards remain feasible. Translation for anyone new to this: powerful enough quantum computers could eventually break the encryption protecting almost everything online, from bank transactions to government secrets. The safeguards, new quantum-resistant encryption standards, already exist and are being rolled out, but only if institutions actually adopt them before a capable enough quantum computer shows up. Hewlett's bet is that the window to get that transition right is open now and closing. The money isn't starting from zero. This builds on $10 million in exploratory grants the foundation announced back in February, which went to institutions including Stanford's Hoover Institution and Vanderbilt University's Institute of National Security, with another $10 million planned through the rest of this year. So the $100 million is really a scaling up of something already underway, not a first step into unfamiliar territory. The initiative breaks into 3 buckets: protecting critical infrastructure, power grids, water systems, hospitals, from AI-enabled threats; addressing vulnerabilities in fast-moving technologies, specifically naming biotechnology and quantum computing; and supporting global governance, helping the US, allied governments, and other capable actors build responsible rules and norms for these technologies while keeping American leadership intact. Foundation President Amber Miller framed it this way, quote, "Rapidly emerging technologies like AI hold extraordinary promise while posing novel security challenges. We view embracing progress and tackling safety risks as natural complements, not competing approaches." And Eli Sugarman, who's directing the initiative, put the mission in more human terms. Quote, "Too much of the AI and emerging technology debate misses questions ordinary people care about most: their safety and how these technologies impact their families. This is about evidence-based problem-solving, funding creative experts on critical cybersecurity challenges, and convening diverse stakeholders across government, industry, and civil society." Now, here's a detail that matters for how you read this story. Quantum computing is only one of 3 named focus areas, sharing the spotlight with AI and biotech, both of which are arguably getting more political and public attention right now. The announcement itself doesn't break out how much of that 100 million is earmarked specifically for quantum-related work. It's grouped in with other fast-moving technologies. So the deadline number is real, and the intent is real, but the actual quantum-specific dollar figure is something we'll only learn once grants start going out the door. Here's why the timing is interesting. This lands the exact same week Britain dissolved its own dedicated science ministry, scattering quantum oversight across departments with no clear owner. Put those two stories side by side, and you get a pretty clean picture of how unsettled quantum governance still is globally. One government is consolidating tech policy under an AI minister and leaving quantum's institutional home an open question, while a private American foundation is stepping in with real money precisely because it doesn't trust that governments and industry alone will get the safeguards built in time. The skeptic's read here is straightforward, and it's worth taking seriously. This is a grant-making program, not a technical mandate and not a regulatory framework. $100 million sounds enormous until you remember it's split across 5 years and 3 entire technology domains: AI, biotech, and quantum. And AI alone could reasonably absorb the lion's share of both the money and the attention, given how much louder that conversation currently is. The Foundation's own materials don't specify a quantum-specific allocation, so the real test of this initiative isn't the announcement, it's which grantees actually get funded over the next 5 years, and whether any of that funding produces frameworks, standards, or research that a government or a company would actually adopt. There's also a structural question worth asking. Can a philanthropic foundation actually move the needle on something like post-quantum cryptography adoption when the real blockers are usually inertia, cost, and the sheer scale of migrating legacy systems, not a lack of research? Hewlett's own framing leans on its cyber initiative as the model, the idea being that funding independent research shaped an entire policy field over a decade. That's a real precedent. But cyber policy had the advantage of attacks already happening in public, forcing urgency. Quantum's biggest threat, a computer powerful enough to break current encryption, hasn't happened yet, which makes the political will to act on research this foundation funds a much harder thing to manufacture. Compare that to the vendor white papers and government pilot programs we cover most days on this show. Quantinuum and SoftBank mapping a hardware roadmap, Singapore and IBM running an exploratory pilot, and you can see why this one stands out. Nobody's selling anything here. Nobody's trying to move a stock price or land a government contract. That's rare enough in this industry that it deserves credit on its own, even before a single grant goes out. And structurally, funding independent civil society organizations, universities, think tanks, rather than companies, is itself a statement. It's a bet that the safeguards this moment needs will come from research insulated from commercial incentives, not from the vendors racing to sell quantum hardware in the first place. What I'd watch for next: which organizations actually receive grants under this initiative, and whether any of that money flows specifically to quantum-safe migration work rather than getting absorbed into the broader AI safety conversation, which tends to dominate every room it's in these days. Time for the hype check. I'm putting this one at a 6. Here's why. The money is real, it's philanthropic rather than promotional, and the institutional pedigree, 60 years in tech security policy, a track record with the cyber initiative, gives it more credibility than a typical press release. That's genuinely worth something. But the announcement is long on mission language and short on quantum-specific specifics. No named quantum grantees yet, no dollar figure attached to quantum work alone, and quantum sharing top billing with 2 technologies that are going to soak up most of the oxygen in the room. This is a foundation putting a flag in the ground and saying quantum security matters, which it does. But the substance of what that actually buys the field is still 5 years of grant decisions away from being provable. If Hewlett names quantum-specific grantees with real institutional heft in the next few months, I'll bump that number up. Right now, it's promise, not proof. These are threads I expect we'll keep pulling on. Quantum governance is being written in real time, across governments, companies, and now foundations, and nobody's fully in charge of it yet. And if today's stories left you with more questions than answers about who's actually steering quantum policy, that's honestly the right reaction. If this show's part of your routine, hit follow wherever you're listening so you don't miss where this goes next. This has been Quickly Quantum, an AI-voiced podcast, created and built by a real human using today's cutting-edge technology. Nothing you heard on this show is financial advice. I'm Brian Lampert, and I'll catch you all tomorrow. Take care.